In this particular example, we're trying to find the derivative of the function h of x. H of x is defined as 6x squared plus x all cubed multiplied by 4x cubed minus 5x all raised to the fifth. In this particular case, we're going to have to use the product rule to find its derivative. But what makes this question particularly difficult is embedded within that product rule, you will find that we have to use the chain rule twice. H prime of x is going to equal f of x, which is 6x squared plus x all cubed, times g prime of x, which I will just write as d dx of the 4x cubed minus 5x raised to the fifth. I'll take the derivative in the next step. Plus your g of x, which is 4x cubed minus 5x raised to the 5, times f prime of x, which I've written for the time being as d dx of 6x squared plus x all cubed. I'll take the derivative in the next line. In the next line, I've taken the derivative of those two components, and I've been forced to use the chain rule to do so. So I end up with 6x squared plus x all cubed times 5 times 4x cubed minus 5x raised to the 4 times 12x squared minus 5. I add to that 4x cubed minus 5x raised to the fifth times 3 times 6x squared plus x all squared times 12x plus 1. You notice that when I worked out those two derivatives, I did have to use the chain rule. The next step, I have to look at the two terms separated by the addition sign and ask myself what's common to both of those terms. You'll notice that I can common factor out a 6x squared plus x all squared, and I can also common factor out a 4x cubed minus 5x all raised to the fourth from both of those expressions on either side of the addition sign. When I do that, I'm left with, in the squared brackets, 6x squared plus x, which is multiplied by 5, which is then in turn multiplied by a 12x squared minus 5. Add to that 4x cubed minus 5x, which is multiplied by 3, which is in turn multiplied by 12x plus 1. In the last step on this particular screen, all I've done is expanded those terms in the squared brackets. In the first step on the next screen, you'll notice that after I've expanded those particular expressions, what I've then done is combined my like terms. So I end up with h prime of x equals 6x squared plus x all squared being multiplied by 4x cubed minus 5x all raised to the 4 times 504 x to the fourth plus 72x cubed minus 330x squared minus 40x. What you notice is that 2x can be common factored out of the last expression found in those last set of brackets. So we end up with h prime of x is equal to 2x times 6x squared plus x all squared times 4x cubed minus 5x all raised to the 4 times 252x cubed plus 36x squared minus 165x minus 20. This is the derivative of our function h of x.